That's where it comes from. I see. Okay, great. So Daniel, do you have more time now on the farm, less work in winter?
I'm having to take more time because it is like basically on the farm, this is the time to do the planting, and I'm trying to get the food forest planted this winter. So I've been digging very deep holes the last few.
I see. Oh,
I'm starting to get proper muscles from,
okay.
from the work.
From deep ecology to deep holes. Huh?
Exactly. Like today, I literally found myself digging a hole for a cherry tree and then realizing that I found a spot where there weren't really big stones among the clay that is the subsoil. Yeah. And so I got interested in how deep can I go, and ended up digging a 170 meter deep hole. And it started to bring to get some water seepage in. So that's really, because it's been raining for about 4 weeks. So it's interesting that even up on a hill where we are, there is actually water.
It's raining here in California too, luckily.
Nice.
Yeah, we are very happy about it. Okay, so how do you want to do this?
So I would suggest, I mean, we can cut this beginning bit out, but maybe we start off by Tobias just telling you a little bit about the structure of the MOOC and what this conversation is kind of being used for. Tobias, over to you.
Yeah, thank you, Daniel. May I share my screen for just a couple of minutes in order to have some visuals?
Absolutely. And do I need to make you? Make you host. There you go.
Okay, I'm sharing here a mirror board.
Yes.
And just very briefly, so maybe I just make this bigger. So this is just a kind of summarizing visual of this massive open online course we're producing at ETH Zurich in collaboration with the Oslo School of Architecture and Design and Politecnico Torino. And it spanned basically from the idea that at this big tech university, we're somehow lacking this kind of more creative space in between science, in between design and transformative praxis. And I can say that from my own experiences teaching systemic design at ETH for some time. And so the ETH Innovedum, which is a kind of foundation within ETH to fund innovation in teaching, helped us to start this program. It's entitled Designing Resilient Regenerative Systems, on purpose with these terms. And it has a total duration of about 14 weeks. And it's somehow organized in 4 smaller MOOCs. So the entire MOOC is like a series of shorter MOOCs, 4 short MOOCs, and each short MOOC has duration of about 3 to 4 weeks. There was the kind of demand of working with edX, this organization, to have a timely, let's say, short amount of work or week packages for participants. And so these 4 short MOOCs of 3 to 4 weeks, you can see the titles here. The first one is named Worldviews from Sustainability Regeneration, which gives a lot of basic understanding, dealing with crisis and having a different understanding around of these crises. I'm going in detail in a second. The second MOOC is called Beyond Systems Thinking. This is what we are talking about today. The third one is then the kind of fluent praxeologies of systemic design, which we define as a bit of hybridization between science, design, and transformative praxis. And the fourth one then involves a student project, and we illustrate a lot of this theory and design aspects in so-called real-world laboratories. And for this, we picked 3 so far. One is this region of the Piedmont, Italy. This is close to Turin at the French border. You can see here the Monte Viso. And we have been engaged here for quite some years into cross-scalar design from materials and buildings to regional economies. So that's one of the real-world cases to illustrate the theory of this MOOC. The second one is more like a northern climate and culture, Oslo and Hemsedal, and more the focus on alpine urban relations, circularities, and green cities transformation. That spans from our partner school in Oslo and the work we've been doing there in practice for some time. And then obviously Daniel's very central role in this MOOC as also main, let's say, co-designer about bioregional regeneration practices on Mallorca. And we have been there for a week together in June to shoot, film, explore, interviews, and somehow follow Daniel's work of weaving different, systemic designers, let's say, on bioregional practices on Mallorca. So also different climate. All right. And very briefly, maybe it's important, these 4 shorter MOOCs here are somehow wrapped up by a quest here on the left side, a quest as of a set of questions that participants develop and that help them guiding their path in complexity, and also system-oriented design giga mapping. So it's a certain technique from Oslo School to graphically basically keep track on one's own journey through this work. Maybe this is enough. If you want, there's some more, content on these different MOOCs. The one beyond system thinking that we are talking about today has roughly the structure. One is critical system thinking. That would be the focus of today. Then there's others, the view from above, literally zooming in, zooming out to understand when we are somehow, lost in a specific problem, that often it helps obviously to see the broader system. Social networks, we go deep in there, we go deep in resilience as also related to network science, and then circularity in systemic innovation, which then brings us to praxis. That's a bit of wrap up of what we're planning.
All right, thank you. Very interesting. Listen, whom do you work with in Torino?
I had a visiting professorship in Torino, and we work with Pier Paolo Peruccio, Gunter Pauli, and also Silvia Barbero from the
well,
system.
I know a professor who worked with Gunter Pauli, and I keep forgetting his last name, but his first name is Luigi, and he calls himself Gino.
Yeah, Bastignano.
Bastignano, yeah.
Yeah.
Is he involved in that?
He's basically the origin of systemic design at Polytechnic Torino. So he's the origin of the kind of more regional economic perspective on systemic design. So yes, he's part of this whole development. Yes.
Well, please give him my regards. I've worked with him several times in the past.
I happily do so. Thank you.
Tobias, do you want to unshare screen?
Yes.
Excellent. Well, yeah, it was nice for me to see it presented that concisely as well. It's been a project that's been going on for quite some time, but what's the timeline now in terms of launching the new website for the MOOC?
So we're working on the new website, also on a LinkedIn profile for this, and we plan to launch it beginning of January, around January 10. And then we have about 2 months of time to advertise, communicate for the start of mid-March, lasting then all the way to end of July, with a week break between each of the small MOOCs. And then obviously, we see this, as Daniel wrote, as a kind of funnel, a kind of collector for much more, both a Master of Advanced Studies, but also directing to your course, Fritjof, for example. So collecting a lot of interested people who say, well, I want to go deeper. I want to go, in certain other professional courses, but I would also like maybe to have a 2-week regeneration weeding practice on Mallorca with Daniel. So
Wonderful.
This is just the start of much more.
And is this whole program taught in English?
Yes.
Mhm.
And is that customary now at ETH? Are there many English courses?
Yeah, it's I mean, in the graduate part, it's almost all in English. So yeah.
Fritjof, I think the Capra course and also the global alumni of the Capra course would be really interested in this MOOC, and vice versa. The people who are taking this MOOC would just basically get excited about going deeper. And that's partially why this invitation to have this conversation with you today.
It's obvious that the three of us have a lot in common. There's a huge overlap, you know, in what we're doing.
So let's dive straight in. The idea was, Tobias, you're going to start off with some question, and then I finish off with a couple of ones that I add. Do you want to?
As you wish, we can go. I can start, and you just take over when you feel.
Okay.
Yeah. Okay. So, Fritjof, some of these questions are also formulated from a, of course, perspective of this MOOC, because there will be some people who might have a first connection with system thinking.
Yes.
So that's why we have some, let's say, newbie questions in here.
Yeah.
Okay. So, Fritjof, in your rich experience over such a long time, in a nutshell, for someone who is new to the field, what would you say? What is systems thinking, and what is a system?
Well, systems thinking is a term that emerged in science almost 100 years ago. And it means thinking in terms of relationships, in terms of pattern, of connectedness, and in terms of context. And this is extremely important today, extremely relevant to our time, because when you look at the state of the world today, at our multifaceted global crisis, the most striking thing that you observe is that none of our major problems can be addressed and solved in isolation, whether we talk about energy, climate change, the COVID pandemic, economic inequality, or any of these major problems. They are all interconnected and interdependent, and in scientific language we call these systemic problems, and they need corresponding systemic solutions, which means solutions that do not address any problem in isolation, but always in relationship to other problems. So this is why it's so relevant today. And just to give you a little bit of historical perspective, as I mentioned, almost 100 years ago in the 1920s, there was a very exciting interdisciplinary dialogue in Europe involving biologists of the so-called School of Organismic Biology, psychologists of a school known as Gestalt psychology, and ecologists. And ecology was a very new science at the time. And these multidisciplinary dialogues brought forth the insight that the phenomena these various scientists were studying all had something in common, and that is that they could not be explained by reducing the phenomenon to its constituent parts. The essential properties of the whole derive from the relationships among the parts and the processes in which the parts are involved. And so these wholes were called systems. I think maybe it was Ludwig von Bertalanffy with his general systems theory who put the term systems really on the map. But before that, ecologists had a big debate about ecological communities, whether they were living organisms or superorganisms, as they called them sometime. And then finally, they settled on the term ecosystem, which introduced the term systems into science. And so again, the systems approach, the systems view is a view that focuses on relationships and patterns. Now, the opposite view is known as reductionism, and the situation is actually quite tricky, because a reductionist could say, look, take any kind of living organism. Obviously, we know that it consists of cells, and the cells consist of molecules. So eventually, everything goes back to molecules. If we just understand the biochemistry of molecules, we can explain everything. And there's a very subtle flaw in this argument, and that is that although the structures can be explained in terms of the properties of the parts, the properties of these structures cannot be explained by that, because the properties derive, as I said, from the relationships among the parts, from the processes that are involved. And this is what we call systemic properties. And over the years, you know, systems theory and systems thinking has been more or less dominant in the sciences. Usually it played a minor role, but recently it has emerged again very strongly because of the interconnectedness of our world problems, and because of the insight that the network is the basic pattern of organization of all living systems. And everybody today knows that networks are extremely important. We have social networks, we have communication networks, and we have ecological networks known as food webs. And biologists discovered in the 20th century that in fact, all living organisms at all levels of complexity organize themselves as networks. So the network is the basic pattern of organization of life. And this is being more and more recognized. And this is why systems thinking is becoming more and more acceptable in the academic world. It faces still tremendous difficulties, because systems thinking not only originated in multidisciplinary dialogues, but is inherently multidisciplinary, because living systems of all kinds, organisms, social systems, ecosystems, all share the same set of principles of organization and properties. And therefore, systems thinking is inherently multidisciplinary. And as you know, our academic institutions until recently did not at all like multidisciplinarity and have been organized in a silo mentality in a very fragmented way. So it takes quite a bit to introduce systems thinking into our academic culture, but that's what all three of us have been doing, of course.
Thank you very much. Yeah, we have certain periods where we can cut the recording, of course, to take a bit of a break between the questions. So if I may ask a follow-up question, please, Fritjof. In this MOOC, we postulate so-called different ways of knowing to help taking decisions in complexity. Related to this, would you see systems thinking as science or and art or and practice?
Well, if you just speak about language, you know, systems thinking, the systems approach, systems theory, and so on, these are scientific terms. So in that sense, it is a scientific discipline. But thinking in terms of relationships goes far beyond science and is much, in fact, much older than science. Many indigenous cultures and indigenous traditions have been thinking of nature in terms of relationships. There is, you know, an expression in Native American traditions where people talk about living organisms in nature and nature as a whole as all my relations. And of course, today, from the point of view of the history of evolution, we know that this is literally true. We are genetically related to all the plants, fungi, microorganisms, animals, and so on. So to see living nature as all my relations is literally true. Now, I should also add that artists often think, maybe not so much in terms of relationships, but in terms of patterns. When you think about the arts, whether it's the visual arts or the performing arts or music, it's all about patterns. A melody is a pattern. You know, a dance performance in a choreography is a certain pattern. The plot in a novel is a certain pattern of relationships. So artists focus very much on patterns, and this is why I think the arts can be of tremendous help in teaching systems thinking and in practicing systems thinking. This is something that is much underrated today and neglected. There are, of course, shining examples of artists who were also scientists. There are not too many, but Leonardo da Vinci in the Italian Renaissance is maybe the most outstanding example, or the German poet Goethe was both an artist and a scientist. So these examples exist of integrating art and science. And I think the arts can be of tremendous help today, especially also because the arts don't analyze patterns in a rational scientific way. They represent patterns in an emotional way. And so the emotional dimension that comes with the arts, it's very important, because today, if we want to persuade people to change their lives and act differently in the world, rational arguments often don't make it. But if you can get to them emotionally, you have an additional means, and there again, the arts can be very helpful.
Yeah, that brings me to this follow-up questions. How much should we then base decisions in uncertainty on science? How much space is there for personal opinion and also for not knowing, just navigating through questions?
Well, I think it depends on what you're talking about, what kind of decisions. Any really competent and deeply thinking scientist knows that at the edge of science, there's always the unknown. There's always mystery. No matter how much we progress, we always come up against the unknown. There is a very beautiful saying by Blaise Pascal, who was one of the leaders of the scientific revolution in the 17th century in France, mathematician, physicist, and philosopher. And Pascal said, knowledge is like a sphere, and the surface is the border to the unknown. as we increase knowledge, so the surface increases. So the border to the unknown becomes larger and larger too. So let's talk about concrete examples. For example, if in the current COVID pandemic, if you say, I don't need to be vaccinated because the coronavirus will not affect me, or I do, you know, I eat a lot of spinach and that protects me against the coronavirus. Well, that's a personal opinion, but there is a very, very broad scientific consensus among epidemiologists who know about pandemics and who know about their spread. And ignoring this knowledge is, you know, socially irresponsible and I would say immoral. But if you take a question like, for instance, the nature of consciousness, and is consciousness located in the brain? Does it emerge from neural processes? Or is it present in the universe at large? This is a question that science today cannot answer and maybe will never be able to answer. And there, you know, people are very welcome to have their personal opinions. Well, they are always welcome, I should say, to have personal opinions. But when you act on your personal opinion in such a way that if it affects other people in society and if it affects them negatively, then this is problematic and socially irresponsible. So this is a difficult question, and I don't think it has an answer in general. You have to look at things case by case.
And how would you say, do hard science and warm data as of tacit knowledge, such as intuition, traditional local knowledge, correlate for taking decisions in complexity? The kind of two.
Well, I think Tobias, this term of hard science is a little outdated now. It comes from, you know, classical physics, where Newtonian physics saw the world in terms of hard and solid material particles and the forces between them. And then the soft sciences were sort of the humanities that dealt with, you know, thoughts and consciousness and culture and so on. I think today the critical distinction is between a mechanistic linear approach to science and a systemic nonlinear approach. To me, that is the critical distinction. And when you talk about intuition, then I think this is an important point, actually, because every working scientist knows that intuition is extremely important in science. You know, whenever you discover something new, whenever you have a new idea, a scientific model, a scientific theory, it always originates in an intuitive insight. So scientists are very aware of the role of intuition, and you know, there are very highly intuitive scientists, others who are less intuitive, and that is very well known. But when science is presented in our universities, when you are taught science, you're taught as if a scientist would prepare his or her paper, let's say, from a purely rational perspective. You know, list the empirical evidence, draw conclusions, wrap it up, publish it. This is not at all how science works, but this is how it's presented in our schools. And I think intuition and you know, creativity, scientific creativity, is something that needs to be emphasized much more in the way science is being taught.
Jeff, I would like to add something here, because one of your first books was The Tao of Physics, and you were drawing, back then you were mainly a physicist, and you were drawing parallels between the age-old wisdom of the Vedanta and the insights that modern physics had reached through science.
Yes.
How do you feel, like, can we bring in that, as you alluded to earlier, many indigenous traditional knowledge systems also had these key insights that we've now corroborated by scientific research, and bring in this dynamic where because we speak a lot about being informed by multiple perspectives, holding ways of knowing lightly to be informed by different ways of knowing, but then ultimately it's so easy to say, yes, but let's reduce everything to this one arbiter, which is scientific consensus. And it's a very useful arbiter for many decisions, as you pointed out. But how do we work with this dynamic between really putting traditional ecologic knowledge in indigenous science?
Yes, I think my way of thinking about this is to say that most of the phenomena we study in our environment are phenomena that have to do with life. So, when we go out into nature and observe various patterns and processes, whether it's, plants or, ecosystems or, animals or social systems, it all has to do with life. And, the derivatives of, say, economics, management, healthcare, and so on in the human realm, it all has to do with life. And life has evolved in such a way that human evolution and the evolution of other living systems have happened in a process of co-evolution, of mutually dependent co-evolution. And so human beings have developed a very great sensitivity toward life. And for example, recently experiments have shown that people who are sick and who are in hospitals get well much faster when they are exposed to nature. Even just having the hospital bed by the window and looking out into a garden is therapeutic. And so we have co-evolved with nature, and we have many ways of communicating with nature, communicating with life, including ways that are not at all understood by science. Another part of that is the fact that living systems are highly nonlinear, and the current version of systems thinking is very essentially informed by complexity theory, which is a mathematics that is nonlinear, and for the first time has allowed us to model and describe nonlinear systems mathematically. But nonlinearity is very difficult to understand with our rational mind, because our thinking and speaking and writing necessarily needs to be linear. And so approaches like meditation or trance or ritual, or again, artistic approaches to understand living nature are extremely valuable, because our subconscious is nonlinear and can deal with the nonlinearity and can communicate with the nonlinearity of living nature often much better than our rational consciousness.
That's very useful framing. Tobias, you had a follow-on question to that.
Yeah, it nicely measured that. It's about one module in the MOOC as well, design as nature. And the questions around that are somehow how we can develop a new systemic interconnectedness with nature, a new, nature relational culture in today's accelerating times where nested crises are the new normal. And I think you already touched a bit upon that, but the notion, biomimicry, biomimetic design, all these terms, concepts are out there, yet we are still wondering how to curate such a new culture.
Yeah, well, let me give a little more context to my answer. The systems thinking, let's go back to systems thinking and the way it evolved. Systems thinking reached a new level with the development of complexity theory in the 1970s and 1980s. And there is a conceptual watershed between the systems theories of the 1940s, like general systems theory, cybernetics, and so on, and the new theories and concepts based on complexity theory. And so I'm sorry, I lost my train of thought now. I was going to apply this to, yes. One of the discoveries of what I call advanced systems thinking, or systems thinking 2.0 to be a little more fashionable. One of the discoveries is that living systems and life in general is inherently intelligent. And this refers to a new understanding of cognition, the process of knowledge, which sees cognition as very tightly linked to the very process of life, the process of self-organizing living networks. Technically, this is known as the Santiago theory of cognition, because it was developed by two Chilean scientists, Humberto Maturana and Francisco Varela, at the University of Chile in Santiago. And so, according to this theory, cognition is part of all life. All living systems are cognitive systems, and therefore all living systems are intelligent. So nature is inherently intelligent. And as it evolved structures and processes over billions of years, more than 3 billion years, the end result that we are seeing today means that the wisdom of nature is far superior to human wisdom, and the so-called technologies designed by nature, and I use this metaphorically because there are no designers in non-human nature, but the technologies evolved by nature over those billions of years have practically solved all the problems that we have today and are struggling with today in much more efficient ways. And therefore, it behooves us to listen to nature, to study her designs, to use nature as a mentor and as a model. And this is, of course, the approach of eco-design and biomimicry and these various disciplines. Just to give you an example, which biomimicry engineers often cite, when you look at the thread of silk produced by a spider to weave her web, And when you analyze the thread of silk, you will find that gram per gram, it is more resilient and stronger than steel. And so if you think of how we produce steel, then you think of big furnaces, of very loud processes, very noisy processes, and processes that involve toxic materials. Well, the spider does it all at room temperature and completely silently. So, and has a much better result, more efficient thread. So biomimicry now tries to study these processes and mimic them, imitate them. And in the case of spider silk, people have actually been successful. There are two Norwegian, I think two Scandinavian engineers, two women, I don't remember from which country, but they were able to produce synthetic spider silk, and they can now make tennis shoes and all kinds of things out of these materials.
It's a beautiful example. Thank you. Daniel, you want to go for our next question?
I just wanted to add briefly onto that one. The most expensive piece of fabric on the planet is a scarf that has actually been woven out of real spider silk, and it took them years of milking, I don't know how many 10,000s of spiders. And this scarf is very light, but it's bulletproof. It's stronger than Kevlar vests. And it's just fascinating. But just a brief follow-up question on that is this, because you're co-founder of the Center for Ecoliteracy, and we've talked many times before about, you mentioned the Santiago theory of cognition, which to some extent is a scientific theory that overcomes the Cartesian split that has culturally separated our mimetic framing, the way we talk about nature, as something out there that is somewhat separate from culture. How important do you think is it that we actually find new language where, because Tobias was sort of alluding to this earlier with design as nature, because even the wonderful work with the Biomimicry Institute, we often speak of learning from nature, and by putting that from there, nature becomes an other again. I would love your perspective on how important for culture change these kind of mimetic language use changes actually are. And that relates to this concept of meta design, which is creating new narratives and new organizing ideas for our relationship to life as a planetary process, is actually an upstream design intervention that changes everything downstream. It changes how the designer thinks of finding solutions or finding ways of meeting unmet needs.
Well, I think this is a process that happens naturally when we share knowledge and we share understanding and experience. Then, human beings live in language, and we constantly create linguistic networks. And so the new terms that are needed emerge constantly. They emerge at levels of, say, social media used by teenagers who often speak a language that I can't understand now, because they use sort of, slang terms, abbreviations, and so on that I'm not familiar with. And the same is true for, of course, for designers, for engineers, for scientists, for philosophers, and so on. And so the idea of being with nature and being nature ourselves will eventually create the appropriate language. And I think the idea of meta design is an extremely interesting idea. I have observed in the last few years something similar with permaculture. As you know, permaculture is a certain approach to agriculture, which now has a worldwide following. And I've noticed over recent years that these teachers of permaculture now use the term culture in the word in a much broader sense, not just agriculture, but human culture. And the word culture, of course, has this very interesting history that it was originally used in terms of the cultivation of crops, and then was transferred to the cultivation of the human mind, education, and then, the cultivation of community, of distinct cultures, and so on. But we see in permaculture that this is used in this broader sense now. And I think in meta design, those are similar movements, which I find highly relevant and very interesting.
The other thing that I would love to highlight again, because it was one of the real highlights for me in our last conversation that we had, where you shared that in your own journey of learning from being a physicist to really studying life and ecology very deeply, you in formulating the systems view of life, realized how central the notion community actually is to living process. And in this conversation, we sort of spontaneously agreed that one could reconceive as life not just through the lens of individuals and species and the whole Darwinian story, which is very speciesist and individualist, but you could conceive of life as a planetary process, that it is structured through nested regenerative communities at the local, the regional, and the planetary scale.
Yeah. And this is a very good example of the power of systems thinking to understand in this way. So let's start with a living organism, a simple cell or a multicellular organism. And when we observe the expression of life in this living organism, we observe that life is inherently regenerative. So all the metabolic processes serve to regenerate the molecular structures, the cellular structures within a multicellular organism, say a tissue or an organ, and all the parts are continually recycled, and the entire pattern of life is continually regenerated. Well, in order to do so, the organism needs a continuous flow of energy and matter to provide the materials for this continual regeneration. So life is dependent on a continuous flow of energy and matter from the environment. Of course, everybody knows that. This, again, is an example where everyday experience confirms what scientists discovered and focused on recently. We all know that we need to eat, we need to breathe, we need to drink to stay alive. And so no individual organism can exist in isolation. It always has to interact with the environment, most of which is also alive. So it's living organisms within a living environment. And it turns out that in evolution, living systems discovered a very effective way of doing that, and that is to form communities. And this has happened from the very beginning of the emergence of life. When the first bacteria evolved, they formed tightly knitted communities, which are called as bacterial colonies. And subsequently, at all levels of evolution, life has always formed these communities. And within these living communities, life evolved certain patterns of organization, like cyclical patterns of continuously recycling resources, energy systems that take solar energy to drive these patterns, making sure of a certain biodiversity, which increases resilience. And so these various principles of organization are principles of community, or if you wish, principles of ecology. And they show us that the unit of sustainability is not an individual, but is a community. And so this is a very important lesson. Nature sustains life by building and nurturing communities. And if we want to have a sustainable future, then that's the pathway we should go, building and nurturing communities.
And I am currently reading your wonderful book of 50 years of collected essays. And I was struck by just what you explained so beautifully to us just now. There's a essay number 16, Ecology and Community, written in 1994, summarizes all those patterns that...
This is from a seminar I gave to school teachers within the context of the Center for Ecoliteracy in the 1990s.
It's a wonderful article, and maybe that's my last question. The role of eco-literacy and social literacy and economic literacy in order to enable people, as we engage people at the local place-sourced scale, in local communities and in bioregional context, with this big design challenge. How do we redesign the human impact on Earth within the lifetime of the generations alive today towards being regenerative again, like our ancestors used to? What is the role of these literacies, and how do we transfer the systems literacy effectively so people can actually design informed by this systems view of life?
Yeah, this is actually a very difficult task, and I'm glad you're asking this question. Systems literacy and ecological literacy are very closely related, because ecology is a science of relationships among the members of ecosystems, of ecological communities. And so the two really go hand in hand. Social literacy is quite different, because at the human social level, we have human consciousness and culture, and the human ability, or the human dilemma, let's say, which is often referred to as the human condition, the fact that we are biological beings, but we have the possibility to act against our biological nature, because we are able, with human consciousness, to form abstract concepts, and unfortunately often have the tendency to consider these abstract concepts more important than the real living situation. For example, economists today have elevated the role of money from a very useful tool to a purpose of life, or to a social purpose and the defining priority of societies. And so there's this abstract idea of money, which does not exist outside of the human mind, that becomes all important. So when you talk about social literacy and values of society, I think you have to add the faculty of critical thinking. I would say in the extreme case that economic literacy has to be a critical assessment of current economics, because current economics is not regenerative. It is extractive, it is exploitative, and it leads to disaster with this obsession of continuing economic growth, this illusion of continuing economic growth on a finite planet. So there, the literacy has to become critical. Critical thinking comes in a very important way.
Yeah, wanting to honor time as well. Tobias, do you have a final question?
Yes, I actually have two final questions, Mesa, but I try to post them shortly. But
okay.
Since you mentioned critical, Fritjof, so you've been, so much experiences over so many decades in this field of systems thinking, and it's been exploding over the years with so many interrelated terms, from systems thinking to systems change to circularities. We meanwhile talk about 5 types of circularities, including social, reciprocal flows, etc. So for someone new to this, it can be very overwhelming with a lot of jargon. And my question would be, if you have a perspective on simplifying the complexity of the field of systems with maybe some message on core essence that all the different approaches share.
Well, I should say that what I am teaching these days is actually a grand synthesis of what I call the systems view of life. And I'm teaching it, as you know, in a 12-week online course known as the Capra course. And so this course is a very simplified, but not too simplified, summary of systems thinking. And if I were to summarize it just in a few words, I would say that what the systems view of life has shown us is that life organizes itself in networks. That's a key insight. Life is inherently regenerative. It is also inherently creative and inherently intelligent. Now, to lay this out in detail, requires several hours and technical terms and theories and so on. But those are the key concepts, I think. The concept of self-organization, of networks, of regeneration, creativity, and intelligence of life.
And this brings me to maybe my final question. Maybe there is a kind of guiding message to all of us out there getting lost in uncertainty. I personally like the notion of organic emergence, something like being prepared to spontaneously hop on opportunities while being guided by a set of questions or a quest, as much as we can, obviously. So maybe you have a take on befriending complexity and dancing with systems, how to practically navigate in this world.
Yes, I would just repeat what I indicated before, and that is that to do that, we will find it much easier if we do it within communities. So creating not only communities for the sake of sustainability, but also learning communities for the sake of sharing our experience. And this dancing with complexity, as you say, is much easier if it is done in a community, sharing the same values and sharing similar experiences. Because what happens is that as we explore conceptual relationships, which is largely what systems thinking is all about, as we do that in a community, we simultaneously experience human relationships, which means that the conceptual relationships get invested with an emotional dimension of the human relationships. And I've experienced this a few times in my life of teaching, maybe the most sustained and significant experience was at Schumacher College in the 1990s, where Satish Kumar created a global learning community that was learning together and living together and working together for a certain period of time. And I have taken this experience of Schumacher College as a model for my Capra course, where I'm trying to build up a global community of systemic thinkers and activists. And I've taught the course now for 6 years. So I have an alumni network of over 2,000 around the world in over 80 countries. So I think this is what we have to do, to create learning communities and to proceed on the path towards sustainability in by creating and nurturing communities.
Daniel, you're muted.
I'm just saying it's a wonderful answer, because Fritjof and I met 20 years ago at Schumacher College. That's where I got switched onto all of this.
Yeah.
Thank you so much for this.
Okay, well, this is so. Tell me now, what are you going to do with this? Are you going to produce one piece or several pieces?
I guess we have to review this a bit, also in relation. We had a conversation